context means, right, there's a text surrounding this particular example. So there's a word problem attached to it. So we don't, it's not X and Y anymore like on our axes, right? It could be time and height. That'll be a very common one. It could be distance and height, right? Horizontal distance versus height. It could be time and money. It could be number of tickets sold and money, right? So you'll have to be very careful when you label your graph to make sure it's not X and Y. It is actually labeled and it has units attached to it. Okay, so we just briefly touched on that yesterday and how the intercepts as well as the vertex are very important for us. Okay, we're gonna still call them that, but when we look at those numbers that we grab from it, they actually mean something, right? Time and height at any particular point on this graph. So we're trying to model the path of something, in this case a projectile. And another thing I wanted to clarify is the domain and range. I don't do set notation. I don't encourage set notation when it comes to word problems, because if you don't use the variable that the question uses, you lose marks. You can't use X and Y. You have to use, in this case, for example, the one we're about to do, you'd have to use T and H, right? You would have to use those two letters in the squiggly brackets for you to get it right. So I will show you how to do it, but I will not encourage you to do it, okay? I will encourage you to just stick with the interval notation. All right, so here we have the question. The path of the baseball that is hit can be modeled by the equation, and there it is, right? So that is one that you're definitely gonna want to enter that into your calculator and try to graph it. And just to reiterate, ht is the height in feet, and then t itself is the time in seconds. One thing that I want to say here is that moving forward, okay, when you see something like this, everything on the right side is our x. It's our independent variable. It goes along the x-axis, and everything on the left of the equal sign, right, left-hand side, goes on the y-axis. So just by looking at this, I know that every point on the line is going to be time, right, and height in this particular case. How do I know that? Well, this is x, right? And in this case, it's replaced with the letter t, stands for time. So the first number in any coordinate on the line will represent time, and the second number, y value, will be representing the height. Okay, so that's kind of like we're defining our variable here. So first question, it says determine the maximum height of the baseball. Okay, so what you want to do here first and foremost is enter it into your calculator, right? So let's enter this into our calculator. Go to Y1. I will clear whatever I have in there. At this point, plot 1, 2, and 3 should not be selected at all, right? They should be deselected, so not highlighted. And so let's type in negative 4.9 x squared plus 35x plus 4. I'm going to go ahead and enter y2 is equal to 0 already because, right, I'm going to find the x-intercept, so it saves you some time, and then hit graph, okay? And so this is what I had my window setting at before. So what I'm going to do is I'm going to go zoom 6. So we should probably all do it to just reset our window. Zoom 6. And there you have it, right? We expected it to be pointing down because it's negative here, right? And it has a y-intercept of 0.4. Okay, so here it is. So we just need to increase our y max a little bit. So let's go to window. I'm gonna triple it just to make sure it fits. So still doesn't do it, right? So you have to think from here to here is 30, right? So if we doubled what we have in there currently to 60, that'll do the trick. So finding, oh, still doesn't do it. Okay, never mind. One more time. I'm gonna go 120 just to be safe. So double it again. And there you have it. So as soon as you see the full parabola, you're good. Okay. Now, as I said yesterday, the calculator goes past the x-axis, right? It will show you everything. You have to make sure it's a word problem. Now we're sticking to this, right? Because the time can only be positive, and the height in this case, it's only positive as well, right? Because we're talking about a baseball will hit the ground, okay? So it doesn't go below the surface, okay? So we're in quadrant 1. Once you have the graph on your screen, you say it's asking determine the maximum height. The maximum height will be found at the very top of this parabola, which we call the vertex. Okay, so let's go second, trace, and in this case it's a maximum, and we're going to go ahead and find the vertex. So to the left of the vertex, hit enter. To the right of it, hit enter again, and enter one more time, and there you get it, right? So at home it might be hard to see, but it says 3.57 and 66.5. So I'll show you now how I'm going to write this down. So assume that I'm asking you a question like this, and I want you to answer it, right? So A is right here. Find the vertex. You will not have to tell me this, but this is just for you note. Find the vertex, right? Since it is the highest, right? Highest point on the curve. Okay. So we go second, trace, max, right? Or second trace 4. And then you write down the point, 3.57. Always 2 decimals, okay? If possible, 66.5. But it's very important that you don't just give me the point and leave it at that, because you have not answered the question yet. You might think so, but which one of these two is going to answer that question, the maximum height? It goes back to the red one that I give you up here, right? The first number is time, the second one is height. So the answer, to answer the question, it would be this second number, right? So you just write a little statement, right? Maximum height is 66.5, and then you look at the units, and we are in feet, right? What you found is that if the question asks, when will you reach the maximum height? After 3.57 seconds, right? So maximum height of 60 is 66.5 feet after 3.57 seconds. I'm not going to ask you to do this here, the after, because really you've answered it right here by mentioning the 66.5. But I need you to understand that the 3.57 represents the time it took to get to that height. Okay. B, how long does the ball remain airborne? We need to determine the X intercept. Right? So y2 is equal to 0. Second, trace 5. And we're going to get a point out of that. Just zoom in a little bit more here. Right, so we need to determine the x-intercept. This is how you do it. So that's your keystrokes, right? Folks were asking yesterday, keystrokes, yes, every time. You don't have to tell me that you're finding the x-intercept, but you do have to show me the keystroke. So let's go ahead and do that. So I'm just gonna pull second trace 5, and I don't want, I'm just gonna show you, okay? So pay attention here. Some students try to find this one here, and if you go enter, 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 you get a negative, right? A negative 0.11. This one is out of bounds. We omit that. We do not include that, okay? Because you're in negative time, we can't use it. So don't fall for it, right? If it's a word problem, it's from 0 to this point, right? That's how long this ball was in the air. So let's try this again. I want to find this one here. Right, that one right there. So that's 7.26 if you round it. It's 255, so it's 26 that we rounded to. 7.260 is the point. So to answer the question, it remains airborne for 7.26 seconds. Because action starts at time 0, right? And it's up in the air until it hits the ground, and that's when it stops being airborne. So it's after 7.26 seconds. Okay. C. And I'm assuming you can look at the questions, right? But C, I'm just going to read it. Calculate the height of the ball after 1.5 seconds of being hit. Okay. Really asking for a point, and I'll just say this. They give you the time, right? They want to know what is the y value, right? Because it's going to give you the height, right? The second, the y value for us is our height. So how do we do that? Second, trace 1, right? Because we know the x value. And then we say x is equal to 1.5. We're going to get a y value out of that. So the keystrokes are the most important component here to know how to answer properly, right? And so I'm going to go second trace 1, and it's asking me for an entry for x. So I'm going to say after 1.5 seconds, and it's up here, right? So the height of the ball will be 45.48 feet. Okay, 45.48. If you include units, that's all you need to do technically. At that point, I'll give you full marks, right? If you do that. If you want to put a little sentence after that, that's probably best, right? You just say it'll be at a height of 45.48 feet. It'll be at a height of 45.48 feet. And that's based on this model, right? And so I could ask you, you know, how long, right? What's the height after 3 seconds, after 4 seconds? Could I say after 8 seconds? This ball hits the ground after 7.2, right? So after 8 seconds, according to your calculator, you're below ground, right? Your ball is below the ground. So don't, that would not be acceptable under these circumstances because there's a context, right? There's a word problem associated with this equation, okay? Hope you're okay back home. This shouldn't be too bad, right? Because it's just keystrokes. And so next we're going to answer D. D is tricky. D is a 2-mark question, just so you know. Like if you want to know, how much would a question like D be worth? It's a 2-mark question. So I'll actually write that down when I answer this. There you go. D, 2 marks. Okay. Normally. So what we do here is we let, right, we will let y2, let's read the question one more time though. I'll read it for you. D is asking, how long did the ball remain at or above 49 feet? At or above 49 feet. So what we're going to do is, we know that 49 feet is represented by a y variable, right? Because it's the height. So we let y2 equal to 49. And then we will go second, trace 5. We'll find those intersections. Okay. So before we go ahead and do that, I'll tell you what our plan is. Okay. So to have a visual, maybe over here. Right. So if this is the graph, just a sketch. Okay. This is time and this is height. We know that the graph does not start right on the ground. It starts somewhere at 0, 4. Then it goes up and it hits the ground like this, right? 49, the line y equals 49 is probably going to be, let's graph it so we have a better idea. So let's go y2 equals 49. I'll just show you here. It's right about there. So it's closer to the top here. So just for reference, we're going to graph this here, a straight horizontal line. Right, this is the y equals 49 line. Okay. So you can look at my calculator or you can look at this graph that I'm just giving you here. The ball is thrown up, right? Time goes by, and then at this point you are at height of 49, correct? We're gonna go and find out what this time is. Like, when do we start being at 49? You keep going, right? You keep going, the ball is above 49, and then there's a point where it comes back to 49. Okay? So the time that went by from here, the first instance on your way up and on your way back down, right? This is the time that we're going to have to figure out. How long did it take to go from here to here? Okay? So what we do here is we find what I call time 1 or x1. Right? We can call this x1 and this we call x2. And let's go and find what these two are. So I'm going to go second, trace 5. Go closest to the first one. So enter, enter, enter. And I get 1.68. But we're going to use these numbers to come up with the final answer. When you do that, you want to use twice the decimal point. So you know how I asked you to round to 2 decimals on your final answer? Here we're going to grab 4 decimals because we're going to use this to find our time spent at or above. So I'm going to write down 1.6816, so round to 4 decimals. Okay, and I'll make a note somewhere up top here after. Let's go find the second instance, second trace 5. enter, 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 and that is 5.4613. If you don't do this, there's a chance that your final answer will be off slightly. So that just means you're not going to get the full 2 marks. You're going to get 1.5, right? So if you want to get full marks, do that. Okay. So we've got those 2 variables. So how do you find how much time has gone by between these 2? You subtract them, right? If you subtract the end time and the start time, right, then the difference between these 2 times is going to tell you how much time was spent at or above. Okay, so we're going to say delta time. Delta just means the difference, okay? You should get used to that because you will encounter that in other courses. Physics, right? Delta time is just x2 minus x1. And so you can just say t, right? Delta t is, it's always the greater number minus the smaller one, right? And then you just use your calculator to figure that out. And that is 3.78 seconds. We are in seconds, right? This answers the question. Okay, I will say down here, round to 4 decimals. And then the final answer gets rounded to 2 decimals, okay? Maybe I'll use a different, maybe orange or something different. Right, like this is the time, right? Like this is the stretch of the path that we're interested in, right? And we find the time it happens on its way up and back on its way down. And so that's basically the difference in the times there is what you're interested in for something like this. And the last question is graphing, right? Yeah. So graph. Since this is a word problem, right? Only include quadrant 1, okay? Very important. Do not go past, like some students will, I can do that up here, right? But just don't write it down. Some students will like keep going and put arrows here like this. It's like, no, this is a word problem. This is not acceptable now, okay? Because then you're going against the domain and range. Oh, I did not make you do the domain and range. Oh, I'll do it after. I'll add it after the graph. Okay. Okay. Here's when I'm going to use my ruler. Okay, so you have your y-axis and the x-axis. Right? Something like this, and you can make it work, right? You can make the scale fit your particular graph. Just have to be smart about it. Before you do anything, right? I'm going to say what goes along the x here. It's time and it's in seconds. Done. What goes along the y-axis is height. It could be meters, it could be feet. In this case, it's feet. It could be inches. So watch out for that. This is not always going to be time, folks. It could be distance. Distance means horizontal, right? Sideways. It could be distance and height. And so you got to watch out for the wording. So we've got this figured out, not going to lose marks there. Now I'm going to figure out my scale. I'm going to be looking at my vertex. So where's my vertex? I have it figured out. I'm going to tell you it's 66.5, right? Is the highest y value to account for. So make sure you go to like 70 or something like that. So along the y-axis, let me count 10, 20, 30, 40, 50, 60, 70. It's going to work out. So if it doesn't, then you just have to change your scale or make that line longer if you have room. Okay? So I'm going to go label every other one. That's clear. That's all I need. Along this, so you don't want to cram your graph into like a small little curve you can barely label, right? That's why I mean, like, look at your numbers. I'm going to do this here right now with you. I'm going to write down my vertex here to help me. 3.57. Is that right? Yeah. 66.5. Because remember, I always told you to find these in order to graph. So I'm just, for your sake, I'm going to write them down here, because that's what I base my graph on. The y-intercept is 0, 4, which is not 0, 0. So I'm very picky with that too. A lot of students think it's always going to start here at the ground. No, it doesn't. Okay. It's from the graph, right? Because you're going to ask yourself, what? How did he get that? That's where I got that from. Okay. So my x-intercept is 7.26. So I have lots of room here. I can go up by 1, right? So 1, 2, 3, 4, 5, 6, 7, and I kind of messed up a little bit. So you have two choices. I erase this arrow and I continue a little bit, or I go 2, 4, 6, 8, right? If you go 2, 4, 6, 8, it's going to be a bit of a cramped in graph, so you can do that, but I'm just going to fix it like this, no problem. Right, so it's 2, 4, 6. I know this is 7, and then only need to go a little bit past 7, so that is going to work for me. So if this is 10, 0, 4, this should be 5 here, so 0, 4 is just below that. I'm going to place my vertex. This is 3.5, right about here, right? And I'm going to go all the way to 66.5. Right about there. And then 7.26 is right about here. Okay. Make sure you don't go on the origin, just a little up. And here you gotta just use art, use your artistic skills. I think what makes the biggest difference is to go out a little bit on your vertex. Don't go straight to the point you want to go to. Just go out and then curve. No arrowheads. Okay. I'm just gonna make sure I have my equation. That is important. But it's right there, Mr. Dirksen. Why? Because it needs to be clear that you're adding it to your graph. Okay. That would be there you get full marks. If these points are where they're supposed to be, right? And I'm gonna label them. Okay. And 3.57, 66.5. And the one that I would like you to really become proficient at is the domain and range. Because I'm going to ask that guaranteed, okay? on a test. Not every question, but it's going to be on there. Next year, grade 12 applied, guaranteed. You got to know your domain and range. The domain and range is also known as restrictions. What are the restrictions that this parabola needs to have for it to accurately represent the situation? Right? Because technically the parabola goes domain is negative infinity to positive infinity. But for this, in this particular problem, it goes from time 0 to 7.26. So it's 0, 7.26. And this is the X intercept. If you look back in your notes, I told you that most of the time it'll be 0 to X intercept for your domain. Don't have infinities there. And for range, this is what throws students off. Well, you start at 4 and you go to 66.5. So they'll put down 4, 66.5, right? However, they forget that you do come back to 0. So you're actually you need to include 0 as the lowest y value all the way to the vertex, the y value of the vertex, which is 66.5, like this, square brackets. And if you'd like me to show you how you do the set notation, you'd have to do it this way. In this case, the variable that the equation is using is t. Right? So you'd have to use it this way. If you want to write your range, you have to use h or h of t. It doesn't matter. If you do that, you have a choice. I would recommend this one, the interval, the top one, because then you don't have to worry about variables. You don't have to worry about, some students, they're nervous. I guess they flip these, right? They say t is less than or equal to 0, and then I have to take marks off, right? So just one less thing to worry about. Okay. We'll do, I think what I'll do now is hand it over to you. Let you practice a bit. Graphing contextual quadratic functions, right? So I want you to try page 6, 7, 6, 7, and 8. They're one question per page. Okay, and you have lots of room to do your work right on there, so you can use all of that space that I've provided. Okay, so page 6. So I didn't give you a whole lot of homework. I asked you to graph, right? 6, 7, 8, 9. So I will give you the rest of today, and tomorrow I will go over them with you. But I really need you to give it a go. All right, I need you to get familiar with it. If you're not 100% sure, give it a try. Worst case scenario, you scratch it and you redo it right next to it. Don't be scared of that.